So for today, we have 4 topics that we're going to go about. First, we're going to have a short review on the definition of a significant figure, why do we have a significant figure, and how do we count variables and determine their number of its significant figures. After that, we are going to work with significant figures. How do we add significant figures, how to subtract, divide, and multiply significant figures, and different rules on what should be our final outcome. Next, we're going to have a review on scientific notation. What is scientific notation? The purpose of scientific notation. How to convert variables into a scientifically notated number. After that, we're going to work with scientific notation. How do we multiply or add them, and the different operations involving scientific notations. First, what is the reason we have significant figures? So, by definition, significant figures is defined as the numbers of the digits that carry meaning contributing to its measurement. For example, you are tasked to measure this table. Now, you can have a lot of data depending on how accurate your measuring device is. For example, you have a very accurate measuring device which can measure up to this value. Okay, which means that this table from there to there, it can measure up to a millionth of a meter. So ganun siya ka-specific. However, if you look at a tape measure or this device, if you look at it, it won't be able to detect up to this specific value. Since when you look at that device, drawing natin siya dito, when you look at that device, it will be divided into certain calibration. And if we want to imagine a value as specific as this one, it means that from here, it should be divided up to a millionth degree. And that wouldn't be possible. First, there's no device that can do that. The other thing would be you won't be able to actually see, no, unless you have this super zoom eyes. Now, this one can be possible. There are measurements which can accurately measure up to a meter, 1 meter, and up to 0.26 of a meter. This is also possible, but the device would have to also be very specific, meaning the calibration should still be divided into up to this certain value. Among the three, we can safely say that the second one would be the most possible. But kindly take note that all of the three here, they're actually correct. They can be the same measurements. But possibility-wise, physically-wise, the second one can be the most feasible. Okay. So how do we count significant figures? So we have here 5 rules that we have to follow when we are trying to count significant figures. First is that we have 0 for cosmetic purposes only. Why do we say it's cosmetic purposes? Because the 0 here, if you have here a decimal value and you have here a number, this value, for example, 0.01 will still make sense, but it seems kind of weird. That's why we put another 0 here for, again, cosmetic purposes. Let me erase that one. Okay, next one is we have here what we call the leading zeros. We also call that leading zeros. So leading zeros are not significant because they are just used as a placeholder to determine where this number should be. So they are not significant. The 3 now will be significant. So first, kindly remember that all non-zero integers are determined as significant figures. We now have two zeros here with different positions. First, the zero in between a non-zero number. Okay, so kindly remember that zeros on a non-zero integer is deemed significant. Another thing is that we have here what we call trailing zeros. And trailing zeros are significant. Okay, they have their own value. Okay, so however, there's a rule here. Trailing zeros are only significant if a decimal point is present. Meaning, if there's no decimal point here, this will be deemed not significant. But in our case here, meron, so they are significant. Okay, let's try. So we have here different variables, different numbers, and we'll try to answer if they are significant or not. We'll start first with 2.45. So according to the rule, these are all non-zero integers, which means you're going to have 1, 2, 3. The answer here would be 3. Next one, we have 0.0012. We have here 0 for cosmetic purposes, and we have leading zeros, which means these these 3 zeros here are all not significant, which means we're going to only have 1, 2 significant figures. The answer here would be 2. Next one, we have here 4,000. However, as you may observe, these are what we call, again, trailing zeros after a non-zero integer. However, there's no decimal point in this value, which makes it only contain one significant figure. Now, what if you want all of this to be significant? What you're going to do is put a decimal point here, which will make the 3 zeros here significant. So that you're going to have now 1, 2, 3, 4 significant figures. This 3 here, actually this 4 here, they are all 4,000, but this time it's scientifically notated. So we have here a non-zero, so we're going to cut it 1. However, this one here, it's a trailing zero. However, if you're going to observe, we have here a decimal present, which makes this trailing zero a significant figure. So you're going to have here 1 and 2. Next, we have the same value, but this time you don't have a trailing zero and you don't have any significant figure. You don't have any other value here. So it's a non-zero integer, which makes it 1. You only have 1 SF in this number. So it means that the scientific notation is not counted as a significant figure or a not significant figure. You just ignore them. Next number is you have here a cosmetic zero and a zero in between a non-zero integer. And as per rule, that will be counted as 1, 2, 3. You're going to have here 3 significant figure. Okay, Next one, we have 65.002. You have 1, 2, 3 non-zero integer, and you have here two zeros in between a non-zero integer, plus you have here a decimal point which will give you 5 significant figures. Next one, you have here 1, 2, 3 zeros. However, they are leading zeros, and kahit meron tayo ditong decimal point, they will not be counted as significant figure. They are all leading zeros and a cosmetic purposes zero. But however, you have here a non-zero integer which will give you 1. Next one, you have 32.50. You have 1, 2, 3 non-zero integer, and you have a trailing zero. You have a decimal there which will give you 4 significant figure. Last one, you have 1.260 times 10 to the 6th. And then you have here a trailing zero. You have a decimal there, which gives you a value of a 1 significant figure. Non-zero integers all counted as significant figure. You have 1, 2, 3, 4. So you'll have 4 significant figure for this problem. Okay. So we're now going to proceed on how we work with significant figures, meaning we're now going to apply our knowledge in significant figures in answering problem sets. When working with significant figures, we have different rules for different operations. First, we have here addition and subtraction. So when adding and subtracting values with significant figure, what we're going to follow is the least number of decimal. Okay, so for short, the least precise. Since 12.456 is more precise than 4.5, we're going to follow the least precise, which is 4.5. This has one decimal, and then this has 3 decimal. So when we try to add them, so when you put that on your calculator, you're going to have a value of 16.956. So since we have to follow the 4.5 least precise or one decimal, we have to cut our answer within this one. And since this is already 9, what we're going to do is we have to round off. So when we say we have to round off, we either round up or round down. We have here 5, 6, so that's more than 50, which means 9 will have to be 0, and 16 should be round up, which will give us a value of 17.0 as our final answer. Again, kindly remember that you have to box your final answer for it to be recognized. Meanwhile, when we try to subtract value, first, identify which is the least precise. You have here 2.2, which will give you 1 decimal. You have here 1, 2, 3, which has 3 decimal. Simply put, you have to follow the value here. You can just put it in your calculator, but if you want to solve them manually, you assume zeros here, but you do not count them as a decimal. You just assume. If you put this in your calculator, which you are perfectly allowed to do, you're going to have a value of 18.698. And then since you have here 1 decimal, you have to cut your answer here, which means you either have to round up or round down. In this case, you have 98, and that should give you the decision that you have to round up 0.6. That will now be 0.7. Your final answer will be in 18.7. Next is when you're trying to multiply, divide, or square root. This time the rule will change. Instead of following the decimal or the least number, of decimal, when you multiply, what you're going to follow now, multiply or divide, you're going to follow now is the least number of significant figures. So you're going to start by counting the least number of significant figures. So this one, you have 3 significant figures. All of them are all non-zero integers. This one, you have 2 non-zero integers, which means the lowest is 2. So when you try to multiply that, you're going to have 1360.8. You have 1, 2, 3, 4, 5 SF, and you have to convert that into 2 SF. So which means you have to cut right about here. No? You have to cut right about here. You have to round off or round off by rounding up or rounding down. Now, we have some concern here since it's 1000, but you have to limit it to 2 significant figures. First, what you have to do is try to, round up first this value kung saan nyo ikakat. So that's 13, this is 6, which means you're going to have 14. Okay? So you have 2 significant figures here. However, that's number 14. It doesn't make sense since you should have 1000. Which means you actually have here a decimal value there from here. So you can move from 1, 2, and then 3. So that will give you 1.4. 1.4. And then you have moved 1, 2, 3. So that means you have times 10 to the 3 as your final answer. Sometimes, it is also customary that if the value here at front is number 1, it's okay if you try to move further bit with the number. Which means instead of rounding off, you can just write down 1.36 times 10 to the 3 because you still moved about 3 decimal value. So this would give more mas napapakita niya yung ating correct answer. It reflects more on our final answer instead of this one. But both of them can be considered as correct answers. Next one is we try to divide 2156 divided by 3.48. You plug that in your calculator. You're going to have an answer of 619.5402299. Now, it doesn't mean na sobrang daming numbers na binigay ng calculator nyo na yun na agad ang inyong final answer or ang inyong significant figures. So, since we have here 2 different value, you have 2156, you count the significant figures, that's 4. Then this would be 3, meaning your final answer should only have 3 significant figures. And you should cut right about here. This is 0.54. That's more than 50, which means you have 620 as your final answer. Okay, or you can also have, you can move 1, 2. You can also have 6.20 times 10 to the 2. However, kung hindi naman sobrang laki yung inyong final answer, such as 620, you don't have to put it in scientific notation. Next one is use square root 48.6. The answer that is 6.971370023 in your calculator. However, when you look at our answer here, at our question here, you only have 3 SF, which means we have to cut right about here. This is 1 and 3, 13, that's less than 50, which means this should be retained as 6.97. This is your final answer when working with a significant figures. Next thing that we have to learn is how to write scientific notation. First, what is the purpose of writing scientific notation. In a nutshell, it makes writing and reading, of course, very small and very, very large numbers. So, for example, you have there the Avogadro's number, which is 602, 602 zillion something, basta 602 and 200 followed by lots of zeros. And if you have to write that down, it will take you some time. No? And bago ka pa makasagot, naubos na yung oras mo sa pagsusulat ng number ng question pa lang. So, what we do is we try to write it down in a scientifically notated way. You also have there the speed of light, which is 3 million meters per second. No, 3 trillion meters per second. And if you write it down, still it will take you some time. So you write it as 3 times 10 to the 8 meters per second. You also have the frequency of visible light, which again, 6 followed by 14 zeros hertz. And we write it down as 6 times 10 to the 14 hertz. You also have the different radius of an atom. Small, very, very small number. That's why it's 529 meters and a lot of zeros before. So that's the purpose of scientific notation in a nutshell. We usually convert or write numbers in scientific notation by using what we call the power of tens, or times 10 to the superscript number, times 10 to the 1, times 10 to the 2, times 10 to the 3, and so on and so forth. So what does those values means? It means that the value of 10 is multiplied by 1, that's meant that will give you, of course, 10. Then 10 times 10, that will give you a value of 100. And cubed 10 will give you a value of 1000. So something like that. To remember it easily, it just means that, for example, 10 superscript of 3, it just means that you have a 1 followed by 3 zeros. Diba? Mas madaling matandaan. It means if you have 10 over 5, it means that you have 1 and then followed by 1, 2, 3, 4, 1, 2, 3, 4, 5 zeros, and so on and so forth. Same thing if you have here a negative exponent. A negative exponent, since it's negative the other way around, so papunta sa kabila, which means that if you have 10 with an exponent of negative 3, it means you have 1 and then you have 3 zeros before that value. Since when we try to write it in exponential form, the usual way is to write the first variable and then you put a decimal behind it. So for example, you have here 5243. 5243 simply means, if you want to put it on a scientific notation form, it means that you have 5.243, you multiply it by 1,000. Okay? So if you multiply that by 1,000, it means that 1,000 here also means that, as you can see here, it's 10 over 3, which will give you a value of 5.243 times 10 to the 3. If you have 125, you have here 1 to 3, 3 numbers. That means that you have 1.25, multiply it with value of 100. That means you have 1.25, and then 100 also means 10 with an exponent of 2. So that's 1.25 times 10 to the 2. If you have, for example, 6 million, 6 million simply means that you have a value of 6 and then you multiply it by a million. And again, according to our table, 1 million simply means you have 1 followed by 6 zeros. So that's 6 times 10 to the 6th. If you have a negative number such as 0.004, it means that you have 1, 2, 3, 4. You have 1,000 up to 1,000, and then you have 4. So 4, and then 1, 2, 3 followed by 3 threes. That means 1, 2, 3. That's 10 to the negative 3. So that's how you do it. Remember also that a positive exponent means that the number is shifted to the right. A negative exponent simply means that the decimal point is again shifted to the left, such as this one. Papunta siya sa left to 3. Dito naman, papunta sa right, yung zeros natin. Okay. Another thing that you have to consider is that you can also write them in different form. For example, 5243 can also be written as 524.3 times 10 to the 1, because if you have here, you can assume here that the decimal is here, and if you have moved one place there, it's a positive value, it means that you have moved once the decimal value. That is also equivalent to 5243. You can also move twice, which means 1, 2, your exponent would be 2. However, by convention, we usually write them with a first value followed by a decimal number. Bakit 5243? Because you started with 4SF and you should also end with 4SF here. Going to our second example, you have 125. 125 can also be written by moving one decimal point, and that will give you 1, the power of 1, 10 times 10 to the 1. Or you can also move twice, that will give you a value of 2. And again, by convention, we follow one number followed by a decimal point and then the other numbers. Okay, this one, as you can see, we started with 1 SF. Okay, which means our final value should also be 1 SF. And from here, you can move once, that will give you a value of 600,000.0. Since you move once, the exponent will be raised to 1. If you move twice, that will give you an exponent of 2. However, as per our significant figure, this will now already have a lot of significant figure since you already have a decimal value. But since we started with 1 SF, our final value should also be 1 SF, such as 6 times 10 to the 6. This one, we started with 1 SF also. That's 0.004, which means we have to also end with 1 SF. You can answer it by moving the dot once, which is to the right, since it started as a negative point. Ibig sabihin, from here you move to this point, that will give you 0.04, and then since you move once, your exponent would be negative 1. Okay, remember that if you move the numbers to the left, your number to the left, okay, the 0 to the left, you are going to increase your exponent, such as the examples here. Meanwhile, if you move to the right, your number or the decimal point to the right, it means that your exponent should decrease. Okay. So now we are now going to try to work with scientifically notated numbers. We have two different processes. First, we'll start with what do we do when we are adding and subtracting variables. First is that all numbers are converted to the same power of 10, and the digit terms are added or subtracted. Sir, ano pong ano pong power of 10. For example, on example number 1, we have 4.215 times 10 to the negative 2. And we have times 10 to the negative 4. So what power of 10 would you use? Actually, it doesn't matter. Okay, it doesn't matter what power of tens would you like to use. Okay, so you also have here the decimal. So we per rule we should still follow that, since we have here one decimal value, which means our final answer should also have one decimal value only. Okay, so first step is to convert them. So you choose if you want to convert times 10 to the negative 2 into times 10 to the negative 4, or lower it down. On my case, I want to adjust times 10 to the negative 4 and make it times 10 to the negative 2. So I'll just write this down directly. That's 4.215 times 10 to the negative 2 plus, since I have to convert this, 3.2. I already have times 10 to the negative 4, and this is 2, so I have to move twice only. So moving twice, 1, 2, it means my decimal would be here. I'm going to add here 0 and another 0 here, which means my number will now become 0.032 times 10 to the negative 2. Again, because we have moved to the left, our exponent should increase as I have explained a while ago. If you move to the left of your variable, your exponent again should increase. Okay, so from here we'll just um, um, solve them as per their uh, process, which is addition. So 4.215 times 10 to the negative 2 plus 0.032, you're going to have an answer of 4.247 times 10 to the negative 2. We just have to copy the exponents since pantay na sila. Now, we have here two decimal, and then we add them, so we have to follow the two decimal. So from 4.247, this would be 5. That will be 4.1 decimal. So 5. This will still be 2. 4.2 times 10 to the negative 2. So that is our final answer. Okay. Sometimes we don't follow the decimal, but in our case, we want to follow the least decimal when we're adding and subtracting. Next, we have 8.97 times 10 to the 4th minus 2.62 times 10 to the 3. This time, what I want to do is I want to increase the 3 and make it 4. So I'm going to write this first. 8.97 times 10 to the 4 minus. So from times 10 to the 3, I'm going to write it down, 2.62. And for me to increase this exponent, what I have to do is to move to the left. Kasi diba, when you move to the left, you increase your exponent. So I'm going to move to the left, and my value from 2.62 will now become 0.262, and this will this will increase. This will now become times 10 to the 4. I can now subtract them as per process. This will give me a value of 87080. I need it to be times 10 to the 4, which means if this is the decimal here, 1, 2, 3, 4, that I'm now going to have a value of 8.7. This is 8, this is 0. I have here the least decimal is 2, so this should be 8.71 times 10 to the 4th. That is now our final answer. Okay, so this time we're now going to try to solve problems involving multiplication and division with scientific notation. Kindly remember that when we try to solve problems involving this one, the digit terms, which is the value before the exponents, is multiplied or divided in a normal way. And then after that, the exponents are either added or subtracted. The end result is changed so that there is only one non-zero digit to the left of the decimal. Okay, so it's better to observe that. So we're going to answer example number 1. First step is you have to convert everything in scientific notation, following, of course, their significant figures. This only has one SF, so which means when you convert that, 1, 2, 3, 4, that will give you 8 times 10 to the negative 4. Since you move to the right, means negative 4 has shifted from the left. Next, you have 6 times 10 to the 4. You'll just copy that because that's already on exponential form. This one, you have to move 1, 2, 3, 4, 5. So you have moved 5. So that will give you 4 times 10 to the negative 5. Why 4? Since you only have one significant figure here, your answer should also have one significant figure there. Okay? So from here, pagsasama-samahin nyo lang yung digit terms at yung exponents. So this will give you 8 times 6 multiplied by 4, divided by 4, multiplied by their exponent, so that's times 10 to the 4. Yeah, times 10 to the 4. And you have times 10 to the negative 5. So this is your equation there. So from here, you can just go about and put that in your calculator. They're going to have their 12 times 10. And as stated here, you'll add or subtract them depending on what part, kung nasa taas ba sila or nasa baba. So you have 4. Do you have positive 4? Or rather, negative 4. You have negative 4. Since they are on the upper part of this equation, it means you have to add them. Negative 4 plus 4. And then since eto nasa baba, that would be minus, the value is negative 5. So minus 5. When you try to compute that, that will give you a value of 12 times 10 to the 5th. However, as stated here, you should only have one non-zero digit to the left of the decimal, which means from 12, we have to move one space here to the left. Since you move to the left, your exponent should increase. That will give you 1.2 times 10 to the 6. So this is now your final answer. For example number 2, you have 2.4 times 10 to the negative 6 multiplied by 8,000 divided by 6 times 10 to the negative 3. Same process, convert first. Since eto, naka-exponent na siya, hindi na natin siya papakialaman. Meanwhile, this one, 1 SF, so you have to move 1, 2, 3. And that will give us a value 8 times 10 to the 3. It's a positive exponent because you have shifted from the right. Divided by 6 times 10 to the negative 3, already an exponential exponent on scientific notation, so hindi na natin siya papakialaman. Okay, next step, katulad nito, hihiwalay natin yung ating mga digit terms. So that's 2.4 multiplied by 8 divided by 6. Multiplied by their exponent, so that's 10 to the negative 6 multiplied by 10 to the 3 divided by times 10 to the negative 3. Okay, we'll now try to solve them. Plug that in your calculator and you're going to have 3.2. So that's 3.2 times 10 to the something. So negative 6, pareho silang nasa taas. So negative 6 plus 3, nasa baba. So that's minus negative 3. Okay, so minus minus, that will be plus 3, negative 6. So that will give you 3.2 times 10 to the 0. And according to the table a while ago, times 10 to the 0 is equal to 1. So the times 10 to the 1 times 1 times 10 to the 0 means times 10 to 1. So that means the final answer is 3.2. Okay, so that will be how you'd multiply and divide values with scientific notation.